Connecting a 4 AWG bare copper ground wire to a plastic water pipe is generally not a recommended practice. Plastic water pipes are not considered reliable grounding electrodes according to the National Electrical Code. The purpose of grounding in an electrical system is to provide a safe path for fault current to return to the source, thereby tripping a circuit breaker or fuse and preventing electrical shock hazards. The National Electrical Code, or NEC, outlines specific requirements for grounding electrical systems to ensure safety and proper function. Grounding ensures a low impedance path for fault currents, allowing protective devices like circuit breakers to quickly interrupt the circuit in the event of a ground fault. This minimizes the risk of electrical shock, fire, and equipment damage. The NEC specifies acceptable grounding electrodes, which are conductive objects that make a direct electrical connection to the earth. Acceptable grounding electrodes include firstly, metal water pipes, secondly, metal frames of buildings, thirdly, concrete encased electrodes also known as UFA grounds, and fourthly, driven ground rods or ground plates. Metal water pipes can serve as effective grounding electrodes because they typically extend underground and provide a large contact area with the earth. However, the NEC has specific requirements for using metal water pipes as grounding electrodes, including supplementary grounding electrodes and protection against corrosion. Metal frames of buildings, if adequately grounded, can also serve as grounding electrodes. This is particularly common in large commercial and industrial buildings where the metal frame provides a substantial connection to the earth. Concrete encased electrodes, or UFA grounds, are grounding electrodes encased in concrete near the bottom of a foundation or footing. These electrodes provide a reliable connection to the earth due to the large surface area in contact with the concrete and the surrounding soil. Driven ground rods are copper or copper-clad steel rods that are driven into the ground to provide a grounding electrode. The NEC specifies the minimum length and diameter of ground rods, as well as the required depth of installation. Ground plates are metal plates buried in the ground to serve as grounding electrodes. Ground plates are typically used in areas where it is difficult to drive ground rods due to rocky soil or other obstructions. Plastic water pipes are not included in the list of approved grounding electrodes because plastic is a non-conductive material. Non-conductive materials do not allow electricity to flow easily, making them unsuitable for providing a reliable path for fault current to ground. Connecting a bare copper ground wire to a plastic water pipe can create a potential shock hazard. If a fault occurs in the electrical system, the bare copper wire could become energized, and anyone touching the plastic pipe could receive an electrical shock. Bare copper wire is an excellent conductor of electricity and can easily transmit electrical current to a person in contact with it. Using a grounding electrode that is not approved by the NEC can also create a dangerous situation. If the grounding electrode is not properly sized or installed, it may not be able to effectively carry fault current to ground. This could result in higher voltage levels on metal parts of electrical equipment, increasing the risk of electrical shock. The NEC provides detailed requirements for the size and installation of grounding electrodes to ensure that they can safely handle fault currents. These requirements vary depending on the size of the electrical system and the type of grounding electrode used. For example, the NEC specifies the minimum size of the grounding electrode conductor, which is the wire that connects the grounding electrode to the electrical system. The size of the grounding electrode conductor is based on the size of the service entrance conductors. The NEC also requires that grounding electrodes be protected from physical damage. This can be accomplished by installing the grounding electrode in a protected location or by using a protective covering. In addition to grounding electrodes, the NEC also requires that all metal enclosures and equipment be properly grounded. This includes electrical panels, junction boxes, and metal conduit. Grounding metal enclosures and equipment helps to prevent electrical shock hazards by providing a low impedance path for fault current to ground. The NEC specifies the methods for grounding metal enclosures and equipment, including the use of grounding bushings, grounding lock nuts, and equipment grounding conductors. Equipment grounding conductors are wires that connect metal enclosures and equipment to the grounding system. These conductors provide a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. The NEC specifies the size and type of equipment grounding conductors that must be used. The size of the equipment grounding conductor is based on the size of the circuit conductors. The NEC also requires that equipment grounding conductors be installed in the same raceway or cable as the circuit conductors. This helps to ensure that the equipment grounding conductor is always available to carry fault current. In addition to grounding, bonding is another important safety practice in electrical systems. Bonding is the process of connecting all metal parts of an electrical system together to create a common electrical potential. This helps to prevent voltage differences between metal parts, which can create a shock hazard. The NEC requires that all metal parts of an electrical system be bonded together, including metal conduit, metal enclosures, and metal equipment. Bonding can be accomplished by using bonding jumpers, bonding bushings, and other approved bonding methods. Bonding jumpers are short lengths of wire that connect metal parts together. Bonding bushings are used to connect metal conduit to metal enclosures. The NEC specifies the size and type of bonding jumpers and bonding bushings that must be used. Grounding and bonding are essential for electrical safety. By following the requirements of the NEC, you can help to ensure that your electrical system is properly grounded and bonded, protecting people and property from electrical shock and fire. If you are not familiar with electrical grounding and bonding practices, it is best to consult with a qualified electrician. A qualified electrician can assess your electrical system and make recommendations for improving its safety and performance. They can also install grounding and bonding systems in accordance with the NEC. When evaluating grounding systems, it's crucial to understand the role of impedance. Impedance is the total opposition to current flow in an alternating current circuit and includes both resistance and reactance. A low impedance grounding path is essential for effectively clearing ground faults. The lower the impedance, the greater the fault current that will flow, and the faster the overcurrent protective device will operate. High impedance grounding systems, on the other hand, limit the fault current to a lower level. These systems are used in some industrial applications to reduce arc flash hazards and equipment damage, but they require careful coordination and monitoring. The grounding electrode system should have sufficiently low impedance to ensure proper operation of overcurrent devices. The NEC specifies maximum impedance values for grounding electrode systems. Regular testing and maintenance of grounding systems are also essential to ensure their continued effectiveness. Ground resistance testing can be used to measure the resistance of the grounding electrode to earth. High resistance values indicate a problem with the grounding electrode system, such as corrosion or loose connections. Visual inspections can also identify potential problems, such as damaged or corroded grounding conductors. Proper grounding and bonding are not just about safety. They also play a critical role in the performance and reliability of electrical equipment. A well-grounded system can reduce electrical noise and interference, improving the performance of sensitive electronic equipment. It can also help to prevent voltage transients and surges, which can damage equipment and shorten its lifespan. In summary, grounding and bonding are essential components of a safe and reliable electrical system. Understanding the principles of grounding and bonding and following the requirements of the NEC is crucial for protecting people and property from electrical hazards. It's recommended to consult with a qualified electrician for any questions or concerns regarding grounding and bonding practices. This ensures adherence to the NEC and safe operation of electrical systems.